Our last stop in the series of solving quadratic equations is to look at those quadratic equations which have complex solutions as their answers. And we're going to use two methods to solve these trinomials. We're going to solve them by completing the square and by using the quadratic formula. So first, we're going to look at completing the square, and we're going to solve x squared plus 8x plus 25 equals 0. So for completing the square, we need to have our x squared and our x term alone on the left side, which means this has got to move over to the other side. So to do that, we subtract 25 from both sides. We get x squared plus 8x. I'm going to leave a space, and on the right I get negative 25. Now to fill in that space, I'm going to complete the square. I'm going to take half of the middle term and then square it. Half of 8 is 4, and then if I square that, I get 16. But I can't just add it to the left side, I have to add it to the right side as well. Now I'm ready to write this trinomial as a binomial squared. It'll be x, right, square root of the first term, square root of the last term, sine of the middle term. And on the right, I get negative 9. Now, you already might be looking at this thinking, but wait, how can something squared be equal to a negative number? Which is exactly what points us in the direction of knowing that this is going to have a complex solution. So my next step to get rid of that quantity squared is to square root both sides. And when I square root on the left, I get x plus 4. When I square root on the right, I can split this up into the square root of negative 1 times the square root of 9. And by taking that negative 1 out, we know that the square root of negative 1 is equal to I. So I have x plus 4 equals plus or minus 3i, right? The plus or minus 3 comes from here, and the I comes from here. I just write the number first. I'm almost done. I haven't solved for x yet, so now I have to subtract 4 from both sides. So minus 4 and minus 4. When I do that, I'll get x equals negative 4 plus or minus 3i. And that is my solution. All right, let's solve the same problem using the quadratic formula. So in case you forgot, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to plug in my value of a is 1, b is 8, and c is 25. So I'd have x equals negative 8 plus or minus square root of 8 squared minus 4 times 1 times 25 all over 2 times a, which is 1. Excuse me. I can simplify this a little bit. Negative 8 plus or minus the square root of 64 minus 100. Right? So negative 8 plus or minus the square root. 64 minus 100 is negative 36. And we can take the square root of negative 36, right? The square root of 36 is 6, and the square root of negative 1 is I, so I would get 6i. Now, only because I can do it to all three numbers, right? All three of these numbers have a common factor of 2. If it had only been 2 out of the 3, you can't simplify any further. But because all three of these numbers have a common factor of 2, I can simplify a little bit further. I can divide each of them by 2. Divide by 2 here, and I get 4. Divide by 2. Divide by 2. So my final answer is -4 plus or minus 3i. And you can see we found the same solution from both methods. All right, let's look at another one. All right, let's solve by completing the square first. We've got 2x squared plus 5x plus 1. So we need to get our x terms alone, so the 1's got to move over. We subtract 1 from both sides to accomplish that. We have 2x squared plus 5x, I'm going to leave a space, and then minus 1 on the other side. When completing the square, the x squared can't have any number out in front other than 1. So that means we have to factor out the 2. When I factor out the 2, I get x squared plus 5 halves x. I'm going to leave a space. Equals -1. And now I'm going to have to take half of this and square it. Well, half of this is going to be 5/4. If I square 5/4, I'm going to get 25/16. But you know what? I'm going to stop right here, because if completing the square is the more complicated of the two methods, then why use it? Right at this point, because it's going to start to get complicated, and I've got 25/16, and then I've got to double that and then add that on the other side, it's going to get kind of messy. So right here at this point, I would stop using completing by, for this problem, I would stop using the method of completing the square and instead move to quadratic formula. So here it is again, -b plus or minus square root b squared minus 4ac all over 2a. So when I plug in, this is my a, this is my b, this is my c. So I would have x equals -5 plus or minus the square root of 5 squared minus 4 times 2 times 1 all over 2a, which is 2 times 2. So actually, I'll write it down here. So I get -5 plus or minus the square root of 25 minus 8 all over 4. And then I would get -5 plus or minus the square root of 17 over 4. Now, this doesn't have a complex solution. This, unless we're taking a square root of a negative, I don't need to use complex numbers. So if I take the square root of 17, I'm not going to get a complex number. I'm going to get an irrational number. So these are my solutions for x. This is what x equals. Those are my two solutions. They are not complex solutions, but they are irrational. All right, let's look at one more. So let's start off by completing the square just like we did the last two times. If it becomes too complicated, then we'll switch over to quadratic formula. So x squared minus 10x plus 37. I'm going to move the 37 over to the right so that I have my x terms alone on the left. X squared minus 10x, leave a space. I'm going to take half of this number and then square it. So half of -10 is -5. When I square that, I get 25. And I'm going to add that to the other side. I'm ready to write my binomial squared. I take the square root of the first term, the square root of the last term, and the sign of the middle term. On the right side, I add these together. Negative 37 plus 25 will give me negative 12. So this is where I know that this one is indeed going to have a complex solution because I'm taking a binomial and squaring it, and I'm getting a negative number. So let's keep going. My next step would be to square root both sides. When I do that on the left, I'll just have x minus 5. When I do that on the right, I'm going to have the square root of negative 12. Now, negative 12, I'll just write it over here, can be broken up into the square root of 12 and the square root of negative 1. The square root of 12 can be broken up, which is, we know that this is I. The square root of 12 can be broken up into the square root of 4 times the square root of 3. And the square root of 4 is actually 2. So we get 2 root 3 for 12. And then don't forget the I. So on the right side, that means we're going to have plus or minus 2I root 3. You always want to write the number out front first, then the I, then the radical. So when I add 5 to both sides, I get x equals 5 plus or minus 2I root 3. And that's our final answer. Now, it wasn't, of course, the radical makes things a little bit more complicated, but we would have had to do that even if we used quadratic formula. So this way, we've already done it with completing the square. We don't really have to do it using quadratic formula, but I would like to show you what it looks like just so that you can compare, so that you have an idea of which one you would rather use. So this will be our A, this will be our B, and this will be our C. So we have x equals negative b, which would be positive 10, plus or minus the square root of b squared minus 4 times a times c all over 2a. So that would be 10 plus or minus square root of 100 minus, let's see, 4 times 30 is 120, 4 times 7 is 28, so minus 148 all over 2, which is 10 plus or minus the square root of negative 48 all over 2. And now we have to break down the negative 48, just like we had to break down the negative 12. So negative 48 can be written as, square root of 48 times square root of negative 1. Let's start with that. So we know that this is equal to I. So we keep going with the 48. 48 is 16 times 3. So this can be rewritten as 4 root 3. So now we put these two pieces together, we're going to replace this part with 4I root 3. So we're going to have 10 plus or minus 4I root 3 over 2. And because all three of these numbers are divisible by 2, let's simplify and divide by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. 2 divided by 2 is 1. And I end up with 5 plus or minus 2I root 3. So same answer, different method. Whichever one you're more comfortable with is the one that you should use. But I do want to point out that in both methods, we had to simplify what was underneath the radical. So there's no way to avoid that part. But other than that, if you feel more comfortable with completing the square, use that method. If you prefer a quadratic formula, use that method.